All right, hello and welcome to my advanced chemistry instruction tutorial. Today we're doing naming organic compounds 2.8 in the book, so let's just get on with it. So this is some chemical nomenclature about inorganic compounds. Now you might know that organic compounds often contain, or they do contain carbon and hydrogen, sometimes with oxygen, nitrogen, or other compounds, but all the other compounds are known as inorganic compounds. Now, most of the time you can recognize one when it contains any sort of transition metal or anything like that. Something it's pretty easy to tell something that you wouldn't expect to be found in nature is usually an inorganic compound. Table salt, that's inorganic. Um, this table I'm working on, stone, that's inorganic. Wood, cellulose, that's organic. It's only carbon, hydrogen, and oxygen. Um, I made a typo. All others are, it's supposed to say inorganic compounds. All right, let's go on. So some various types of inorganic compounds are ionic compounds. Now these, we'll go into cations first because we're going to go into how we name these, how the nomenclature works. So with metal cations, the name most of the time is the same as metal. So sodium, a sodium ion, Na+, that's just a sodium ion. That's what it's called. It's the name. Um, Now this is the case for all metals except with metals such as transition metals that can have more than one charge. Um, this is like iron, for example, Fe2+, that's iron 2 ion, or Fe3+, that would be the iron 3 ion, and we notate those with Roman numerals. Now, there are some cases like silver, zinc, and cadmium that stick with their normal charges, but these are pretty hard to tell on their own. So whenever there's a transition metal, just try and use Roman numerals because it's better to use it when you didn't have to than to use it when you should have used it. Um, and sometimes with these different charges, they use Latin names, like Fe2+ is ferrous, the ferrous ion, and Fe3+ is the ferric ion. And with copper, Cu+ is the cuprous ion, and then Cu2+ is the cupric ion. They're kind of weird. They're mostly memory-based. Most of the time you don't have to know these, but I would just be able to identify them if need be. And then a lot of the non-metal cations end in the ium ending, like the ammonium ion or the hydronium ion, which is the H3O+, which is a basic solution. So that's an excess of H+ ions. Now getting into anions. So most anions end in the "ide" ending. That's like the OH- is hydroxide, and a couple others like hydride and oxide. All those end in the "ide" endings. And this is also the same with some of the polyatomic ions, like Cn-, that's the cyanide ion. Like I said, the OH- ion, and the peroxide ion, O2, 2-. But then we're going to get into this a little later. It starts to get a little weird with the oxyanions. These are things like ClO4- or SO3-. All of these are kind of weird in their naming conventions. Oh, SO3 2-. That's what it is. All these are a little weird, and I have information on how to name those, but it gets a little strange because the endings change up and there's suffixes and prefixes and things like that. But we'll get into that in a minute. But for now, we'll just keep going with the anions. And so adding an H+ ion or two to any, let's see if I can move this, there we go, to any given ion adds the hydrogen or dihydrogen beginning to it. So H2PO2-, PO4-, sorry, another typo. That would be the dihydrogen phosphate ion instead of just the phosphate ion. So the addition of that, the hydrogen changed the name, and you can see it also changed the charge because normally the PO4 ion would have a 3- charge, but then adding those H+ adds to the charge. Okay, so these 8 ions, that's the ending that the oxyanions use. So we start off with the root ion. So with sulfate, which is the 8-ion oxyanion, that is SO4 2 minus. And so for all the oxyanions, except for the ones we need to memorize, it's 4 oxygens along with the actual atom that you're looking at. So the sulfur and then the 4 oxygens, and that's a 2 minus charge for this case. With phosphate, it's 3, but these charges are kind of on a get-to-know basis. With others, however, there's a thing called the elbow. I don't know really what it is exactly, but you can see from the borate, it goes up, down the period, and then down the group. So with the chlorate, the bromate, the iodate, the reference ion, which is the starting ion, so that's the one that ends in 8, you can see that there's actually one less oxygen atom than in the other ones outside of the elbow. So when you do the roots, like apply the 8s and the ites and things like that, you're going to just be using the same thing except with one less oxygen atom for the ones in the elbow. Now, it's important to know the rule for naming these. When we have the reference ion, it's just the 8. But then when it's one less, you use the ite ending. So instead of chlorate, that's chlorite. And if there's 2 less, so that'd be ClO minus, just 1 O, that would be hypoendite. So with the chlorate, that's hypochlorite. And then if there's one more than the 8, you add a per beginning. So that becomes perchlorate. So that's a little weird, but I guess that's something you'll get to know eventually. And then more with naming oxyanions, you can see here in the corner is an example of a couple of naming conventions with them. So when you're naming the compound, it's the name of the cation and the name of the anion, which I have listed right here. So with that aluminum cation and the perphosphate anion, it's just aluminum perphosphate. So that's the case with also right there you can see calcium chloride. These are all ionic compounds. So the name is just the cation followed by the anion. So let's go over a couple practice questions. So I'll have you name some of them. Take a moment to take your best guess, I guess. So because this is an anion, it would be known as the bromide ion. Not the bromine ion, but the bromide ion. All right, next one. This one we saw before. We saw the chlorate ion, the ClO3, but since it's in the elbow, it doesn't have 4 to begin with, so we need to add the per on it. So perchlorate ion, because there's 4 oxygens. All right, next one. This one's just a simple ionic compound, so it would be the cation and the anion. So iron 3, remember the 3, because of the 3 charge, because of the chloride's minus charge, and then chloride. Next one. This one is a little weird. You can see that anion, you might not be familiar with it. It has 2 instead of the normal 1 of the number of elements that isn't oxygen. So you would add the di prefix to the beginning of that. That's a little weird, and it's on the list of ions that you need to know. But this one kind of speaks for itself, I guess. You combine the 2 names. That's magnesium dichromate. The dichromate ion will be one of the ones you will probably have to know. And all right, that's it. So thank you.